This is the introduction to section 12.3, part 2. And remember in part 1 we talked about inscribed angles and how the inscribed angles are half the measure of its intercepted arc. And in this one we're going to talk about three little theorems here, and they're still tied to inscribed angles and their intercepted arcs. We saw a little bit of this today in class as well. So let's take a look here at the first corollary. It says two inscribed angles that intercept the same arc are congruent. So, as we look at this example here, you'll notice these two angles right here, angle B and angle A. If I were to, again, follow those angles here, let's take angle B in red. If I were to follow the angle, here's the angle. Those are the two chords that make up that angle. This is the arc that makes up angle B, okay? And if I follow angle A in blue, here's the first chord and the second chord, and you'll notice that these two arcs are exactly the same, okay? So what they're saying is if two inscribed angles intercept the same arc, the two angles are equal to each other. For example, this might be equal to maybe 76, which would mean angle B is 38, and angle A is also 38. Okay? Second corollary says an angle inscribed in a semicircle is a right angle. Well, the reason being, again, here's angle C. Angle C, if I follow angle C, it intercepts the whole semicircle here. Semicircle is 180 degrees. Well, if I divide that by 2, that means this guy, angle C, has to be 90 degrees. So anytime a inscribed angle is in a semicircle, it intercepts in a semicircle, then it's going to be a 90-degree angle. And then finally, the third one, the opposite angles of a quadrilateral inscribed in a circle are supplementary. Okay, in this case, angle A and angle C are opposite, and angle B and angle D are opposite. So, in other words, angle B plus angle D equals 180, and angle A plus angle C equals 180. Opposite angles of each other. These are opposites, and these are opposites. Will add up to be 180. They're supplementary if they're inscribed in a circle. Okay? Okay, now let's take a look at some examples here. And we'll go up here to letter A. It says, what is the measure of each numbered angle? So we want to find the measure of angle 1. Now, there's a couple different things that you can look at here. You'll notice as you see the center of the circle, and you'll notice you have a diameter. So there's a couple ways that you can look at this. First, you could say that since this area right here is 40 degrees, I know this is 140 because it's the rest of the semicircle. So this arc right there is 140 degrees. Well, if that's 140 and this is 40 and that's 70, that's 110. That's 250. That means there's only 110 left over. And you'll notice a lot of times what I'll do is I'll try and find the measures of all the arcs around the circle first, because it's going to help me find the angles much easier. Okay. Now you'll notice angle 1 here. If I follow angle 1, it wants to find the measure of angle 1. So here's the vertex. If I follow out angle 1 and angle 1, this is the arc right here that is incorporated with angle 1. That arc is a total of 180 degrees. So in order to find the angle, I take the angle equals 180, the arc, divided by 2. So the angle is going to equal 90 degrees. Now, another way you could have recognized this was that the diameter goes across right here, and you'll notice the angle is intercepted, the angle intercepts the semicircle. So you know that's 180 degrees. This automatically has to be 90. That's another way to see it as well. Okay. All right, second example. Let's move it on over here to letter B. Okay. Letter B, I see that I have an angle of 38 degrees. If I follow the angle of 38 degrees out here, that means this arc right here is going to be 76 degrees. Okay? Which means if that is the case, then angle 2 is going to be 76 divided by 2, which is 38 degrees as well. This is the case where you have an intercepted arc right here. This angle intercepts the arc. And then angle 2 intercepts the same arc as well. 76 degrees there and 76 degrees here. They're the same arc. Okay? So you'll notice that as we go through this, in this case, these two angles intercept the same arc. Alright, let's take a look at the last example. It says in the diagram here, what is the measure of each numbered angle? Okay, so as you look and see, you'll see you have a dotted line here that is considered a diameter. And so that kind of gives it away a little bit here. Now, as I measure this, as I put this down here, I'm going to put down my list of arcs here, and then my angles here, and the arcs that go with these angles. We're going to go angle 1, angle 2, angle 3, and angle 4. And we're going to figure out how much these angles are. Okay, so now, as I look at this, I want to find all the arcs possible first. That's the first thing I want to do. Find all my arcs that I can match up. Again, I told you earlier that a lot of times if you can find all the arcs, it's going to make it much, much easier. You'll notice the red dotted line. Okay, where I have the red dotted line here, this is the diameter, so that means this is the top half, and that's the bottom half. You know the half is 180, so if you already have 60, that means that this arc right here is 120 degrees. And on the bottom, if you already have 80, that means this arc is 100 degrees. Essentially, I just took 180 minus 60 and 180 minus 80. Now, once you know all the arcs, the angles are going to be easy to find out, because you're just going to add certain things together. So we'll start with angle number 1. If you follow angle number 1 here, you follow it out, it intersects the semicircle, so the arc is 180 degrees for angle 1, which means if you take 180, you have to divide that by 2, and angle 1 is going to be 90 degrees. Now, angle 2, if you follow out the angle here, the two chords, you have 100 plus 120. So that means angle 2 is 220 degrees. That's the arc that goes with the angle. If I divide that by 2, that's going to give me the angle measure, and the angle measure of angle 2 is 110. Now that you figured out 1 and 2, to be honest with you, if we go back to the rules where it says opposite angles of a quadrilateral are supplementary, so the opposite angles will add up to be 180. So before I go through actually how to do this, you could figure out, okay, angle 1 is 90, opposite of that is 3. Those two have to add up, so angle 3 is also going to have to be 90. 2 and 4, those are opposite of each other, so these have to be add up to be 180. Well, 2 is 110, which means 4 is going to have to be 70 degrees. Now, if I didn't see that, how would I figure that out regularly? Okay, so let's take a look at angle 3. Angle 3 is created right here, and you'll notice it's 180 degrees, the 120 and the 60 if I add it together. So the actual arc measure is 180 degrees. If I divide that by 2, that gives you 90. Okay? So then the last one here, angle 4. Angle 4 is the 60 and the 80. If I add those two up, that's 140 degrees, and if I divide that by 2, that's 70. Now you'll notice again, on this there's a couple ways you can figure that out, okay, as you look at that. Okay, so this concludes section 12.3 Part 2. Don't forget to complete your WSQ.